Question 27. Draw the top view. Now take note, if you're drawing the top view, right, imagine you are standing here where the front view is, you're standing from the front and you're looking down. And okay, the thing is for this question, right, you can see most of the cubes, but you can't really tell if just to like confirm if there's another cube behind, because it is right next to this cube, but you can't tell if it's an empty space or not. So you have to read the question. If they say 8 unit cubes, right, then you count. Are 8 unit cubes visible to you, or is there another one hidden behind? So 1, 2, 3, 4, 5, 6, 7, 8. There's nothing behind, right behind this one, right next to this. Okay, you hope you get what I mean now. Maybe I'll just highlight which one I'm talking about. So from the top view, got this. Okay, this is from the top view. So these two first. Then this one above the second one. Then there's one next to it. Then there's one here. So this is what it looks like from the top view. Now B, find the greatest number of unit cubes John can add without changing the front and side view. Without changing the front and side view. Now the front view, what does it look like? Use this. So the yellow one represents the front view. Okay, where else can we add so that the front view and side view doesn't change? Let's highlight the side view. You just focus the one yellow and pink. The side view, front view is like a U shape, right? And the side view is just 6 blocks. Right, the front is like that. Then from the side, it's like that. We can add here 1, 2. Oh, okay, maybe we go by layers. The bottommost layers, right? You can actually fill up everything. It's not going to change. So there's 1, 2, 3, and 4. So bottom layer 4. Again, where's the 4? Here 1. Then there's 2, and then there's one more space behind this, not visible from here. So 1, 2, 3, 4. Now second layer, how many can we have? You can have one above this one, okay, right next to this one. Then the middle row, you cannot fill up anything because it will block the front view already. But behind, you can put 2 more. You can stack 2 more. So one in this row, and then the last row we have 2 more for a second layer. So second layer 3, total you can add 7. All right, question 11. Solid is made up of 1 cm cubes. 1 cm cube means each side is 1 cm. How many more 1 cm cubes are needed to build a cube of each 4 cm. So to get a cube of each 4 cm, how many cubes are there altogether? So we'll take 4 times 4 times 4 first, which is 64. 64 cubes is what we need. Let's find out how many we have here. So in order to count the cubes systematically, I'm going to use this method, starting with the tallest one. Okay, the tallest one is 3 layers tall, right? So in this column, there are 3 and 3 here. Okay, I'm looking like downwards. In this column, there are 3. And in this column, there's 3 also. And the second tallest here will be 2 layers. So in this column is 2 and then 2. Then how many of one layer are there? 1, 2, 3, 4, 5. So 3 times 2 plus 2 times 2 plus 5. Oops. So 6 plus 4, 10, 10 plus 5, 15. How many more do we need? We'll take 64 minus 15, which is 49. Okay, so option 3. Question 8, solids made up of 1 cm cubes. What is the least number of cubes needed to make it a cube? So what's the max you should? The minimum the minimum number of cubes needed for each side is how many? So if you look for the length, right? Here there are 4 cubes across. 4 cm. Then the breadth also 4. Then the height, highest you go also 4. Okay, so the cube that you want is actually made up of 4 times 4 times 4, which is 64. Then count how many cubes do you have. So what I do is I count from the tallest one. The tallest one has 4 layers, so 4 cubes. And the second tallest 3, and then 2. So 4 cubes, 3 cubes, 2 cubes. Then the rest are all single cubes. So like 1, 2, 3, 4, 5, 6, 7, 8. So 4 plus 3 plus 2 plus 8 is 17. How many more do you need? 64 minus 17, which is 47. I need 47 more cubes. Cube that we are forming, you don't need all the sides to be the same. Okay, just go the minimum that you can have. So the length, you can't have anything less than 6. The breadth, you can't have anything less than 2. And the height, you can't have anything less than 3. So the total you need 6 times 2 times 3, which is 36. You need 36 squares. Let's count how many squares do we have. Now I count by layers. So let's say the tallest, no, I count by columns. The tallest column has 3. Second tallest has 2. And then the rest, 1, 1, 1, 1, 1, 1. Total, 3 plus 2 times 2 plus 6. Because all the ones give me 6. This is 13. So how many more do I need? 36 minus 13. 23. Question 19, find the volume of the solid. Okay, how we're going to count this systematically. Let's start off with the tallest column. How tall is the tallest column? The tallest one is 4 cubes high. So this is a 4. Second layer, 3 cubes high. Then the next layer. So if it's 3 cubes high, I write down 3. So I know that I need to add 3 2 times. Then the two layer columns. 1, 2, 3, 4, 5. Okay, maybe let me write down. So 4 plus 2 times 3 plus 5 times of 2. Then the last layer, 1 only, 2 times 1. Okay, so this is 4 plus 6 plus 10 plus 2. This will give us 22. So answer 22 cubic cm. Question 20. Govinda stacked 13 unit cubes and glued them together to form the solid below. So you're supposed to draw the side view of the solid on this grid here. Okay, so let's just check 13 unit cubes. And you have to take it that they start from the bottom up. Okay, so you should not have cubes that are floating. So 13, 4 here. Then 4 below, 4 in the second layer, that's 12 already, right? 4, 4, 4, that's 12. And then the top one, 13. Okay, so we know that this cube here is 2 layers tall. All right. Okay, but sometimes we are not able to tell if there's a cube there. Then you have to count. But this one, okay, this one is quite obvious that there is a cube over there. And anyway, if there isn't, it will not affect the side view. Okay, maybe let's highlight. Highlight where is the side view. Side view, you definitely see this, right? On the side. Then you'll see this. And also this one. Okay, so let's draw the bottom two first. Use a ruler. I can't use a ruler in this case, but you use a ruler. Okay, then you have 3 wrapping around the right one. So here, oops, like that. And then 1 on top of the middle one, the middle column. Okay, so this is what your diagram should look like. Question 27. Gregory glued 9 unit cubes together to form the solid shown. Okay, you're supposed to draw the top view. Now, for the top view, right, you have to imagine you're standing here from the front, and then you look down. Okay, you're not standing at the side, you're standing at the front, and then you look down. Okay, so when you look down on the leftmost, right, the leftmost side, you see 2 cubes. So you start with 2. You use a ruler to draw this. Okay, 2. Then if you look across, there'll be 1, 2, 3, 4. Then below you have 2. So 2. Okay, this is what your diagram should look like. But B, Gregory glued more unit cubes to the above solid to form a cube. What was the least number of cubes used? So firstly, what's the smallest cube that he can form? So the smallest possible cube that he can form, right, without removing, will have a side as long as the longest part of this this solid. Okay, and the longest side will be these 4 cubes. So your cube that you're going to form, right, it needs to have a side of 4 cubes. So the total number of cubes that you need will be 4 times 4 times 4, which is 64. You need a total of 64, but he already has 9. So how many more does he need? 64 minus 9. Okay, answer 55. He needs at least 55 more cubes.
Question 16 is a bit difficult if you cannot imagine, cannot visualize. Then it's quite difficult for question 16. Okay. Now, the wooden block as shown in diagram A was dipped completely into a pail of paint. Then it was cut along the dotted lines as shown in diagram B to form the solid as shown in diagram C. The solid form could be divided into 6 identical cubes. Okay. The total unpainted area of the solid in diagram C is 337.5. Okay. Find the volume of the wooden block at first. Now, let's look at this. This is called the side view. Okay, let's call side view. This is the front view. Okay, just name it. Now, from the side view, how many squares is unpainted here? Now, from the side view, you can see how many squares are there. 1 square, 2 square. Actually, from side view, there's altogether 3 squares. Right? 3 squares on side view, 3 squares. How do I know there's 3 squares on side view? I mean, this. Because there's 3 squares on this side, so there must be 3 squares on the other side. Right? If there are 3 squares on this side, on the side view, this side is shaded, is painted. Right? This side is painted. So the unpainted side view, number unpainted side view, we have 2 sides unpainted. Because on the side view, there's 3 faces, and we know that this face is painted what? 3 minus 1, there's 2 sides unpainted. Front view, we have this side and this side unpainted, right? 2. Back, the same thing. 2 sides unpainted. So the front and the back view will have 4 sides unpainted. Maybe I should use sides. I use square. Square is clearer to you, okay? Use square. Because they are squares, okay? So altogether, there are 2 plus 4, 6 squares unpainted. The question provides that the total unpainted area is 337.5. So 6 squares is 337.5. 1 square will be 337.5 divided by 6. 56.25. Given area of square, you find the sides. How to find the sides? Square root 56.25, you get 7.5. So this is the length of one side of the square. Right? So if I will mark it from here to here is 7.5. All right. Volume of one cube. Volume of one cube will be equal to 7.5 multiplied by 7.5 multiplied by 7.5, and you get 421.875. This is the volume of one cube. So the volume of the wooden block at first consists of 9 cubes. Okay, 9 cubes. So 9 times 421.875, you get 3796.875 cm. So 3796.875 cubic centimeter. Please leave your answer as it is 3 decimal places. Don't be a smart aleck to do the 2 decimal place, because the question didn't ask you to be 2 decimal place. So leave it as 3. Okay. Now let's look at part B. Any question so far? If the question never asks you to simplify to 2 decimal place, leave your answer as 3 decimal, whatever it is. Okay, what percentage of the wooden block is the solid formed in diagram C? So let's talk about part B. Percentage of the wooden block in the solid form is diagram C. Diagram C made up of how many squares? How many cubes? 1, 2, 3, 4, 5, 6. The original block is made out of 9 cubes, so percentage will be 6 over 9 times 100%. And then you get 66.667%. Now, the question wants you to be 1 decimal place, then you convert. Okay? You never ask, leave as it is. Okay, now, let's look at the last question. Question 17.
Okay, question 18. 6 identical cubes are glued together to form a cuboid as shown. Each cube has a length of 1 cm. Cuboid is then submerged fully into a pail of red paint. Find the total area of the cuboid that is painted red. Okay, so let's do it in a systematic order. I'm going to look at the top and bottom first. They have the same surface area. So the top and bottom, let me just show you the top since we can't see the bottom. This is the top, so 3 by 2. So top plus bottom. There, okay, so each surface is 1 times 1. So the top will be, there are 6, so 6. But you want top and bottom, so double it. You get 12 square cm. Now front and back is here. Let's take this as the front. Okay, the front is 3. So front and back is 3 times 2. Three times 2. Next, we have the sides and 2 sides. 2 sides. So each side has 2. So 2 times 2, because there are 2 sides, left and right. Now add them up. 12, 6, and 4. 22. So answer 22 square cm. Question 4. Terry used 1 cm cubes to form a cuboid measuring 45 cm by 30 cm on 45 by 30 by 20 cm. He painted all the faces of the cuboid. So how many of the 1 cm cubes in a cuboid have only 2 of the faces painted? Okay, so first, maybe I just draw so that it's easier to understand. Okay, so this is a cuboid. This is 45. This is 30. This is 20. Now, if he paints everything, right, where are the cubes with 2 of the faces painted? So we are looking at this part here. Okay, the cubes somewhere there. Cubes here. Cubes here. Here. These parts. Okay, and then behind the hidden part. Not the corners. The corners would have 3 sides painted. Okay, so let's look at this part first. Okay, that one is the number of cubes would be 45 minus 2. You minus away the 2 corners. 45 cm, every cube is 1 cm. So 45 cm minus 1 minus 1. That's 43. Now, 43, there are 4 of them. 1, 2, 3, and then behind there's one more. So 43 times 4. 172. Okay, so this part here, those in blue. Okay, next, let's use this. We have along the 20 cm, right? This part here, that is 20 minus 2. So that's 1, 2, 3, and then behind there's one more hidden one. So 18 times 4, which is 72. Okay, 72. And then lastly, you have this part here, this one, and the bottom one is hidden. That is 30 minus 2, 28. Then 28 times 4 of those, which is 112. Now add all of them up. Okay, we want to add this, and this one. 172 plus 72 plus 112. This will give us 356 cubes. Okay, so those are the cubes with 2 sides painted only. 356 cubes. Okay, question number 5. Now this is a